Find the points on the polar curve r equals 2 e to the power of theta where the tangent line is horizontal or vertical, where theta is on the closed interval from 0 to 2 pi. We want to give the location as ordered pairs in the form of r comma theta. When we have a polar equation, the curve has a horizontal tangent line where dy d theta equals 0, and the curve has a vertical tangent line where dx d theta equals 0. Looking at the definition of dy dx above, we do have the formulas for dy d theta and dx d theta. Let's begin by determining where dy d theta is equal to 0. dy d theta equals f prime of theta times sine theta plus f of theta times cosine theta. And f of theta is simply r, which is 2 e to the power of theta. And therefore, f prime of theta equals the derivative of 2 e to the theta, which is still 2 e to the theta. Then we have times sine theta plus f of theta, which is also 2 e to the power of theta times cosine theta. We set this equal to 0 and solve for theta. Let's begin by factoring the left side by factoring out 2 e to the power of theta, which leaves us with the sum of sine theta and cosine theta. Notice the left side equals 0 only when sine theta plus cosine theta equals 0, because 2 e to the power of theta will never equal 0. So now we need to solve the equation sine theta plus cosine theta equals 0. Let's subtract cosine theta on both sides. And let's divide both sides by cosine theta. This is nice because sine theta divided by cosine theta equals tangent theta, and the right side simplifies to -1. Now we're looking for the angles theta on the closed interval from 0 to 2 pi that have a tangent function value of -1. Having a tangent function value of +1 or -1 should remind us of a 45-degree reference angle. Let's begin by sketching a 45-degree reference angle in each of the 4 quadrants. And now let's sketch the reference triangles. Because we have 45, 45, 90 reference triangles, in the first quadrant, we can label both legs +1 where both x and y are positive, and the hypotenuse square root 2. In the second quadrant where x is negative and y is positive, we can label the horizontal leg -1, the vertical leg +1, and the hypotenuse square root 2. In the third quadrant, both x and y are negative, so both legs can be labeled -1, hypotenuse is square root 2. In the fourth quadrant, where x is positive and y is negative, we can label the vertical leg -1 and the hypotenuse square root 2. Recall that tangent theta equals the ratio of the opposite side to the adjacent side. So notice the two angles in the given interval from 0 to 2 pi that have a tangent function value or a ratio of the opposite side to the adjacent side equal to -1 would be this angle, 135 degrees or 3/4 pi radians, as well as the angle in the fourth quadrant, this angle here, which would be 315 degrees or 7/4 pi radians. Notice for both of these reference triangles, the ratio of the opposite side to the adjacent side is -1. So again, now we know dy d theta equals 0 when theta equals 3/4 pi radians as well as 7/4 pi radians. And now let's give the ordered pairs for the points where the given curve would have a horizontal tangent line. Using theta equals 3/4 pi, the first ordered pair would be 2 e to the power of 3/4 pi, comma 3/4 pi. And the second ordered pair would be 2 e to the power of 7/4 pi, comma 7/4 pi. And now we'll set dx d theta equal to 0 and determine where the given curve would have a vertical tangent line. Dx d theta is equal to f prime of theta times cosine theta minus f of theta times sine theta. F prime of theta is 2 e to the power of theta, and then we have times cosine theta minus f of theta, which is 2 e to the power of theta times sine theta. And now we set this equal to 0 and solve for theta. Once again, we'll factor first. The left side equals 0 only when cosine theta minus sine theta equals 0. Let's add sine theta to both sides. And because sine theta divided by cosine theta is tangent theta, we'll divide both sides by cosine theta. Simplifying, we have 1 equals tangent theta. Going back to our reference triangles, we know tangent theta is positive in the first and third quadrants, and therefore now the angles are 45 degrees or 1/4 pi radians, as well as 225 degrees or 5/4 pi radians. Which means the ordered pairs would be 2e to the power of 1/4 pi, comma 1/4 pi, as well as 2e to the power of 5/4 pi, comma 5/4 pi. Before we go, let's verify this by analyzing the graph of the given curve. Looking at the graph on the left first, here we have the vertical tangent line in the first quadrant given by 2e to the power of 1/4 pi, comma 1/4 pi. We can also see this green point in the second quadrant where the curve has a horizontal tangent line given by 2e to the power of 3/4 pi, comma 3/4 pi. Zooming out for the graph on the right, we see the other 2 points in the third and fourth quadrants, where here we have a vertical tangent line, and here at the bottom of the fourth quadrant we have a horizontal tangent line. So the graph does verify our work is correct. I hope you found this helpful.